Hey guys, and welcome to another Factorio Friday Facts discussion number 281 for a few frames more. And I am joined by Afflixian as always.
Hello, everyone.
So, this one is basically the TLDR of the entire thing is graphical optimizations. Now, it's quite technical, very, very text heavy and long. So, Afflixian is going to go ahead and take the lead here and pretty much just summarize each section. We're not really even going to read any of the stuff that's actually here just because it's just a lot of text. And the summary is probably just going to give a better general idea of what's going on.
Yeah, and if you think back to the previous Friday Facts that were really technical and I provided a bullet point summary, that's basically what we're going to do here.
Right.
So as Xterminator just said, the TLDR for the whole thing is graphics optimizations. Yay! And then each section in here is one way that they achieved some of those optimizations. The first one was just fixing a bug. Apparently, they had smoke particles that lived for the entire 120 ticks that they so they had 120 ticks between passes to determine whether or not to draw them. And so some of them were dying in that 120 tick gap, essentially. So they fixed that where things are no longer drawn once they're dead. And they got some speed up from that.
Nice.
Always good. That one's actually a bug. And the way Placilla actually started this off was by saying that Technical Friday Facts helps him summarize what he knows and helps him get a different perspective. That is absolutely a true statement. That's one of my favorite concepts in programming, which is called rubber duck debugging, where you essentially describe the problem that you're having to an inanimate object, and just the process of doing that description helps you figure out what was going wrong.
Right. I mean, I can see that. Yeah, like, basically just kind of talking to yourself in a way. Just voicing it out loud can really help understand things and figure things out you wouldn't have if you're just thinking about it in your head.
Yeah, like the process of sounding it out line by line tells you what the difference is between your thinking and what's actually happening. And that's super useful, especially here.
For sure.
So that's the bug fix that they found. And then they also set a threshold for the opacity that they use to draw things. Anything below 2% just doesn't do anything in the picture, so they don't draw it.
Okay.
Quick tip for the devs here, document that somewhere that's easily accessible, because otherwise people are going to look at it and find out something is going on and think, what is going on here? And then start digging through documentation and make it easy to access. That's all. The next section is turret range visualization optimization. This one is basically, you know how when you turn on turret ranges and you're trying to see where on the screen is in range of your turret. That was actually causing a lot of performance hit.
Interesting.
And so they found a way to optimize that, where they do a pre-pass, and they just check the essentially the circumference of the radius of that turret, and find out if it's in range or not. And go through and draw something over all the sprites. This is direct drawing from the GPU. So they went through a couple different iterations here, and then after further investigation, they found out the GPU really doesn't like early exits in pixel shaders. Pixel shader is a special piece of code that will run on the GPU to actually do the drawing.
Okay.
And so eventually they found a solution that will be 20 times faster in cases that were too slow in the unoptimized solution.
Well, that's good.
So they actually ended up with a hybrid solution where when you're zoomed in, it uses this 20 times faster solution. But when you're zoomed out and there are more turrets covering fewer pixels, the original solution was better. So they turn on the optimization only when you zoom in.
Interesting. Okay, so... I wouldn't have actually thought of that, but if it works better...
Yeah, I mean, the zoom level is configured, or not configured. It's easily accessible. We have player.zoom And the fact that you can change that in the console means they have easy access to it.
Right. That makes sense.
And then, quick aside, artillery range also suffered from the same problem, but artillery range is so big that they just decided to draw a full screen rectangle in that case.
Mm-hmm. That makes sense.
And then GPU performance. This is the next section here. The main thing that they do with the GPU is they read pixels from a texture and blend it into the frame buffer. So it's a lot of memory access, and that is where you're going to find most of the slowdowns in any game that you're working on. Usually the blocking thing is not the amount of processing they have to do, because GPUs can tackle that amount of processing. The blocking thing is memory access, because it just takes so long to go to memory and back.
Okay. Yeah, so it's basically just like the time it's actually taking to go from memory and back rather than the amount of memory.
Yeah, the GPU cores realize that they need to access something from memory, and so they send in a request. And to use the analogy that we used last time, the request is going to the other side of the world and coming back on foot.
Wow. Okay.
That's the level of latency that we're talking about in terms of the speed of the processor and the amount of time it takes to get something from memory. So the way GPUs get around that is that they have the cores work on multiple things at the same time. But in Factorio's case, because they're not doing a lot of graphical processing, they're just drawing to screen. Mm-hmm. They max out the amount of things that the core can do in parallel, and every single task is now waiting on memory. So they're really memory bandwidth limited here.
Okay.
So they made some optimizations here by reducing the amount of things that they need to rely on textures for, reduce the number of shaded pixels by simply lowering the resolution. And they do a bunch of things for that. And the biggest benefit we'll see here is for the lower end GPUs that don't have all the processing power and memory bandwidth available that the higher end GPUs do.
Okay, so I mean, this is good news then for those people playing with, those lower end, less expensive GPUs. This will hopefully help quite a bit.
Yeah, this is a lot of the optimizations here will really help the lower end GPUs. The higher end GPUs really don't care at this point about this game.
Yeah, they just have so much power; it doesn't really matter.
Yeah, this game is like for modern GPUs, or not modern, but for the higher end GPUs, this game is like playing solitaire.
Yeah, pretty much.
They also talk here about something called mipmaps, which is how they downscale and copy the textures to the GPU. That reduces VRAM usage. And they talk about another optimization here where instead of getting an average between the 50% scale and the 100% scale mipmap, they just take the more detailed version and use it.
Okay.
Save some processing power there, and that's two memory accesses, or that's one memory access that they save. They went from two memory accesses to one, which is a huge speed up.
Yeah, that's pretty significant.
And then the next section here is texture compression. This is most of the rest of it, I think.
Pretty much. Almost all of it, yeah.
Yeah, almost all of it, and then just some graphs, pictures at the end. So texture compression is a way to maximize your efficiency in terms of transmitting textures to the GPU. And I'm not going to get into the details here, but there's a bunch of different algorithms that you can use to achieve this texture compression. But the downside of that is all these compression algorithms were made with still images and human eyes in mind. So these are not lossless compression.
Right.
And just real quick, lossless compression means that when you compress something and then uncompress it, you get the exact same thing back. You are not getting that with this lossy compression. Like JPEG as a format is lossy compression.
Yeah.
So the easy way to see that is this first set of GIFs here, uncompressed versus BC3 compression. On the left, everything is crisp. There's no noise in the image. Whereas on the right, you see a lot of noisy artifacts. You see little black dots that appear and disappear.
Yeah, it's pretty staticky.
Yeah, it's staticky, it's noisy, it's a result of the compression. However, they can't really transmit the uncompressed texture because that takes way too much VRAM and bandwidth.
Right.
So they have to do some sort of compression. And so they go on after this set of GIFs and they describe some of the steps that they took. Sometimes they increase the size of or they increase the resolution of the texture so that the noise is further apart. But it's not an option for them because their sprites are pretty small, and it makes things look even worse. They did some more experiments with compression. And like I mentioned before, the most common image and video compression formats, JPEG and H.264, they're designed for human eyes, not for machine readability.
Okay.
So
that makes sense.
They said here, JPEG is it takes advantage of the fact that human vision is pretty bad at recognizing color and is much more sensitive to brightness. So JPEG messes with brightness more than it does with color.
I didn't know that.
Yeah, so it's super technical stuff here about exactly how they do it, which again we're not going to get into. But the point is that we're not going to get a perfect compression, but we can get pretty close.
Right. So then I'm just seeing this last little bullet pointed thing here that in 17, the texture compression graphic settings will have a drop down for none, high quality, and low quality. And the high quality will use the custom compression and will be the default. And then the low quality is for really weak computers. And then I guess not turning it off, they say, is not something you would really do, but I would think that you would.
You should want to have the texture compression there because that's going to increase your performance. If you have to send over the uncompressed texture, that's going to cost you some time in drawing the frame. And if you're on a really high-end computer, you may not care about that. But the default should be the high-quality compression. And they actually say that here. There shouldn't be any reason to disable the compression. The main reason would be to debug some technical issues.
Right.
And then here they show the three different options: the uncompressed, high quality, and low quality compression.
Right, which, you can tell a difference between all of them. However, the high quality compression isn't that much different than the uncompressed.
Yeah, exactly. There should be no reason to use the uncompressed one. If you can get the same quality with less bandwidth, then you should take the one with less bandwidth.
And then one thing I just noticed here is this first paragraph, the first sentence of this next paragraph is, after adding the high-res worms, biters, and splitters, VRAM usage rose to up to 3.5 gigabytes with high-res enabled, obviously, when no compression, even the shadow one, was applied. Compressing to shadows decreased VRAM usage to 016 levels of 2.5 gigabytes. So again, if you're using a card with like 6, 8, 11 gigabytes or whatever, then you should be more than fine.
Yeah, so this is, again, an optimization targeted at the lower end GPUs. And they even say that here. With high quality compression, they use about 1 GB for all the sprites, which means that it's perfectly playable on a 2 GB card.
Right. Which is great.
And then
I mean,
combine that with the texture streaming that they talked about in the previous Friday Facts. Um, if you play heavily modded games that add a bunch of new sprites, then the texture streaming will take care of that for you, and you should be able to get acceptable performance, not perfect, but certainly playable performance with a 2 GB card.
right. So
And
I
then,
think that pretty much is that section.
yeah, almost. High-res sprites, they say, were originally intended for the best computers, but in 17, with these optimizations, high-res is going to be the standard.
Which is fantastic because
Yeah,
it's a huge difference playing with the high-res textures versus not high-res.
yeah, it was a huge difference. I think I started playing right as they switched from low-res to high-res for track, and that was a gigantic difference. The tracks look so much better now than they did before.
Yeah, and I mean, everything's just way more crisp.
Yeah, and then the last thing they mentioned, there were 7 compression formats. The 7th one is actually introduced to DirectX 11 and is not available with anything before DirectX 11 or OpenGL on Mac. So that means they can't use it.
Right. So moving into this next section, it looks like they took some benchmarks from the public Factorio event that I participated in last year. Turns out it was getting frame rate drops.
I remember that.
Yeah, I mean, and that had some pretty extreme stuff in it. So, I mean, this is a good benchmark.
Yeah, I mean, I think you had a world dedicated entirely to nuclear power.
Yeah. I use map. Okay, so they tested on GPUs with 2 GB or 1 GB of VRAM that we have in the office. Benchmarks on the desktop ones ran on a single PC and a 4790K, 16 gigs RAM, Windows 10. They measured the time a frame was being processed for 1,000 frames, averaged out the results, benchmarked against a 17 build from before GPU side optimization were implemented. Unfortunately, we don't have a way to capture GPU timing the 16. And they ran in full HD resolution 1920 by 1080 with high-res sprites enabled. So,
and that should be pointed out, this was in the comments on the forum. Someone was asking about the compression. They used high-quality compression for everything.
Okay, that's good to know. And then they also say they included a result from a high-performance GPU, GeForce GTX 980 4GB, but this was ran in 4K resolution as opposed to full HD. Benchmark of Intel HD graphics 550, 500 was ran on a laptop. So, I mean, this gives you an idea that they can run pretty much max settings at 4K with this 4GB GPU, which is impressive because by today's standards, like if you're getting a GPU that was made within like the last, 3-4 years, it's pretty much definitely going to have more than 4 GB.
Yeah, if you're buying anything like the equivalent of 1050 or 1060 or higher, it's going to have more than 4 GB.
Yeah. So they show a picture of what they're doing, and then we got some benchmarks for smoke. So old and then new. So on the left, on the vertical, we have average render time in milliseconds, and then of course the cards. And you can see a significant difference here. Like some of these are just staggeringly much longer.
The X660, that second one, went from 38 milliseconds to draw the frame down to 4.25.
Yeah, which is nuts. And even looking
the
at
660 the 660 is one step below my first ever GPU.
Really? Damn.
The GPU that I got back in like 2012 or something.
Yeah.
That's fantastic.
Yeah, I mean, so you can with these, you can play Factorio on super old GPUs, but even looking at the newer, much higher level one, there even were fairly significant differences. It's actually cut in half, pretty much.
Yeah, and keep
the
in
amount of
mind,
time
this
it
is
took.
on a very smoke-heavy screen.
Yeah. At 4K resolution, and it's still
Yeah.
half of what it was before, which is pretty huge.
Yeah, this is really good performance gain. Also, keep in mind that they used high-end CPU for this too. So
Yeah.
you need to factor that into account.
Mm-hmm. And then looking down, we have this, and this is decoratives. So I'm guessing for graphical, for the test, maybe they took out all the fancy stuff with tracks or something, because I mean, these tracks are not
No,
normal
what he did,
tracks.
I think he mentioned it somewhere in the text. He added a whole bunch of decoratives in the map editor. So the track is
Okay.
just covered by decoratives at this point.
Okay, so with that, and we know currently decoratives are pretty heavy on your graphical rendering.
Yes.
But looking at this, it's still pretty, again, the 660 massive increase or decrease, whatever way you want to look at it. And then again, even looking at the very high end one, it's still cut more than in half the time.
Yeah, like that. This is the effect of all these optimizations. Obviously, the 980 didn't really need it because the frame time for 60 FPS is 16 and 2/3 milliseconds,
Right.
and this was already under that. But still, the fact that it was cut in half is huge.
Mm-hmm. So yeah, then they just say at the end, times are measured milliseconds, lower times are better, and for 60, yeah, like you just said. If you're interested in how GPUs work more in depth, Fabian Geisen wrote a nice series of articles, and there you go. So super technical, but pretty much this is awesome. Some massive graphical performance improvements over the board here.
Yeah, I'm impressed by this. This is some really technical stuff. I used to do regular processing on a GPU, image processing, and that kind of thing, and I know how complicated it is to interact with the GPU. So kudos to you guys.
Yeah, really great job. The performance increases are just massive. So I believe that's going to do it unless you got anything else to add.
Give us 17, please.
Yes, this month would be great. So there we go, guys. As always, thank you for watching. Leave thoughts and questions below and on the forums if you want to, have the devs see it. But until next